Next, we look at what happens after the issuance. Well, after the issuance, the company watches. They don't do anything about it. They got their money. It's a marketable security. That's what makes the bond market so powerful, is that whoever buys the bond on the first day doesn't have to wait 5 years to get their money back. They could hold it if they like, or they hold it for 1 year, get their interest back, but they can sell it anytime, even that same day. The market is there, and all the bond market there is we have participants. The investment bankers like it because if their clients are engaged in buying and selling, they make a fee. What you'll learn is that investment bankers always make a fee, right? The bond market's active and it's selling and everyone's watching. The company doesn't have to do anything. Now, the company may want to do something. They may say, hey, I've got some extra money around, or I think my creditworthiness is better. So they go into the market and they buy the bonds. They could do what's called a retirement of a bond. So they'll buy back from the marketplace the bond, and then they can get rid of it because they're not going to owe themselves. You can't owe yourself money. That's what we call a retirement. They don't have to do an early retirement of debt, but they always have the right to because they're participant in the market as well. They can buy back and retire that obligation. So people call it buying back or debt retirement or bond repurchase. I think the most precise one is a bond repurchase. So the market still sets the price of the bond, but the company then makes a decision whether it's opportune for them to buy back some of their bonds. Step 5 is maturity. At the end of that entire period, the bonds must be bought back by the company. That's at face value. Whatever the face value is, they're going to pay it. So even if the bond prices were below $100 million, on the last day they get $100 million. And the converse is true. If the bond started at a premium above $100 million, it will then pay only $100 million to retire all of those bonds as well. Bottom line, pay the face at maturity. That's it. Bond pricing, there are 2 rates. There's the coupon, which is the stated rate by the contract, and that's what we use to compute the amount of cash. The cash coupon payment is equal to the coupon interest rate times the face rate of the bond, right? I'm emphasizing those on purpose. All right, the other is the market, or what the effective rate is, or the yield required is. It's what the marketplace wants from the interest. Now, if these are the same, it will be issued at par. But if there's a difference in the two, there is still a market for the bond. It's just not at what the investment bankers and the company expected. So now we're going to go back into sell, and we're going to do 3 scenarios. We're going to keep the face at 100 million. We're going to keep the coupon at 100, but we're going to issue at par, and then discount, and then premium. So let's go into Excel. The top part we've seen before. I'm going to scoot down here to show you an Excel formula. Now what I could do, so the market interest rates are par, which is 0.08, or it could be at a discount, 0.09, or it could be a premium, 0.06. Okay, just as examples. We could have just used our formula here before and said, well, at 9% it's 96. At par value, at 8%, it's exactly 100, right? It better be, because that's by definition. And if at 6%, it's 108, right? So this little formula and Excel sheet on top works, right? It works for any interest rate we would choose to put in. But I'm going to take the opportunity to show to you an Excel function that does the same thing. So the function is called, not too imaginative, the PV, or the present value function. And the parameters, and I'll make this bigger so you can see it better. So the parameters are equals PV, open parens, rate, comma, number of periods, comma, the payment amount, comma, the future value, comma, and the type, close parens, right? That's Excel's very unimaginative when it comes to syntax, and that's what we call syntax, are the factors or the parameters inside the parentheses. So let's just fill this out. So the market interest rate is, in this case, the rate. So I've already put this in, and I'll state this in percent, so it stays in what we've seen before. 8%, 9%, 6%. Par, discount, premium. All right. Number of periods, this is going to be the same for all of the scenarios. It's 5 years. So 5 years is the term. Coupon interest rate. What is the payment? The payment equals the coupon rate, 0.08, times the face amount, 100. And that, by the way, is the same for all of them, because that's how bonds work. So regardless of whether it's par, discount, or premium, the coupon payment's always the same. Coupon rate times face amount. I know I've said it like 6 times already, right? So what is the ending payment amount? $100 million. So if I buy this bond, I'll get 100. So the type is, the default is end of period. In this case, it is end of period. End of the first year, end of second year, blah, 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 until the end of the 5th year. So that we'll just leave as default. And what is the bond price? Now I'm going to do the formula equals PV, open parens, rate. So you just go and point to it. Remember, I hate hard coding numbers. Comma, the number of periods, you see it's bolded, 5, comma, what's the payment amount? $8 million I will receive, comma, what will I get at the end? $100 million. And at this point, I can either put comma 0 or the shortcut, since we're taking the default, is just close parens. I'll pay $100. Now notice the sign is negative. This is from the standpoint of the bond investor. I will pay $100 million to get $8 million a year for at the end of each 5 years, and then I'll get $100 million at the end of the 5th year. If I copy that formula over, I will get what the price is in each of those scenarios. So if my rate that I need is higher than what they're going to pay me, I won't pay $100 million. I'm going to pay less. I'm going to pay $96,000,011. If I'm willing to accept a lower interest yield, here 6% versus the 8%, then I'm willing to pay, as strange as it sounds, $108 million just to get $100 million back in 5 years. Now, why would you pay 108 to get 100 back in 5 years? The reason is each of those interest payments, you're going to get more than you expected, more than you require. You require 6%, right? 6% of 100 would be 6 million. I'm doing this in very rough terms. And they're going to pay you 8, right? So they're going to pay us more money each of the years than what we would say expect or require. So therefore, we're willing to pay more than $100 million to get that cash flow stream. So here, these are the numbers of what the price would be of the bond at par, at discount, and at premium. So let's go back to our PowerPoint. And so we have at par, it's 100. At discount, 96. At premium, 108. The effective rates is what the investors required, and the premium or discount is just the difference from 100. In this case, there's a discount because we got less than 100. In this case, it's a premium because we got more than 100. So that's how that works. So we record the initial issuance, and it's always at how much money we got. That's always the case. Because cash, right? Cash eventually tells us the story. All right, so let's look at an example of interest expense versus interest payment. The short form is the interest expense equals the effective interest rate times the net amount outstanding, whereas interest payments are dictated by the terms of your bond. Specifically, for the 7th time, it is the coupon rate times the face amount. So let's see how that works with an example with Comcast. So they issued 2.75% notes with a face value of $750 million due on March 1st, 2023. Comcast received 99.497, that's pretty close, of the face amount, or $746 million after all the underwriting fees. So that is the amount they got. If we assume that the notes were sold on March 1st when they had the full 7 years remaining, we can then estimate the effective rate. What we would do is on the right side, the coupon rate is 2.75 coupon. The market rate is the 1.415. That's the annual market rate required. The interest payments per year is twice a year. The years to maturity is 7. The face amount is $750. So now the issue price case, we're going to take what we know is the market price, which is $746, and work backwards to the market rate. If we knew the coupon, the interest payments, the year, the face, and the issuance price, we know all of that, then we can use another Excel function called rate, and the parameters are here, equals rate, and the first factor is B4, which is the years of maturity, times B3, which is payments per year. So instead of annual payments, these are semi-annual, which is the most common. So we're going to get 14 payments if we're the bondholder. The next parameter is negative B5, which is the face amount, times B1, which is the coupon rate, that sounds familiar for the 8th time if you're keeping track. Coupon rate times the face amount. But here we're getting 2 payments a year, so we have to divide by 2. So each period we're going to receive a rate. The next parameter is the face amount, which we're going to get on maturity. And here it's a negative 750, and this again is from the payer side. So the company will pay $750 million, and the 0 is accepting the default as end of period payments. And so the rate is 1.4149. That is a semi-annual rate. So if we take that number and double it, it becomes about 2.8%, which is higher than 2.75, which is why it's a discount. All right. So here the numbers are very small, the differences, but we're talking about $750 million. So the face amount was $750. The amount that was paid to the Comcast is $746, a little bit less, which means it's a discount bond, which means the effective rates required by the investors is higher than the rate that they were offering. Here, Comcast was offering 2.75% per year, and the annualized market rate that the investors wanted was 2 times 1.41 or 2.82, right? It's a little bit higher than 2.75, but that's enough to drive it below the face amount and be issued at a discount.